Programming a Terasic Intel FPGA board in VHDL with TINACloud.
In our other videos, we've shown how you can create a digital circuit and download to an FPGA board by using TINACloud's schematic editor.
Programming a Terasic Intel FPGA board with TINACloud using schematic design entry.
And the Verilog hardware description language.
Programming a Terasic Intel FPGA board in Verilog with TINACloud.
Now, in this video tutorial, our circuit, a full adder, will be based on the VHDL hardware description language. The textual description of the hardware greatly enhances portability and reusability. By using hardware description languages describing the fundamental operations, structures, and connections, virtually any logical circuit can be defined. At the end of the video, we'll use
Intel Quartus Prime Lite and a Terasic DE10-Lite Intel FPGA board
to demonstrate the configuration of the FPGA. Now, as we stated earlier, TINACloud works with schematics, but we can also place HDL macros, including VHDL and Verilog, in the design. To learn more about the HDL macro creation and its role in the simulation, watch our video, Creating Macros from VHDL, Hardware Description Languages in TINACloud Part 1. Now let's see an example, a full adder using the half-adder VHDL macros. Start TINACloud, then open the full adder VHDL
DE10-Lite.tsc from the TINA examples /FPGA folder.
Most digital circuits that perform addition or subtraction use full adder. This combinational circuit adds two binary digits and a carry-in to produce a sum and carry out. This 1-bit full adder cell has three inputs, A, B, carry in, and two outputs, sum, carry out, by applying a half adder to accept the carry-in input from the previous less significant stage of a multiple-bit adder. Let's check the VHDL code. Double-click the half-adder VHDL macro. In the Properties window, click the three dots, Details, at the end of the HDL code field. As you can see, the half-adder is described by this very simple 2-line long VHDL code shown on the screen. Close the dialogues. The OR gate can either be schematic symbol or described by VHDL. It requires just one line, identical with the mathematical definition of the OR operation. To demonstrate the power of hardware description languages, note that we could even realize the whole full adder with a short VHDL code, which is also shown on the screen. You can also realize this circuit with a similar Verilog code. See our video tutorial,
Programming a Terasic Intel FPGA board in Verilog with TINACloud.
The circuit operates like a half-adder while the carry-in value is low. Start the simulation by pressing the Dig Interactive button. When both inputs are low while carry-in is also low, then sum and carry-out are also low. While just one input is low while carry-in is low, then sum is high and carry-out is also low. When both inputs are high when carry-in is low, then sum is low and carry-out is high. Now let's see what happens when carry-in is high. When carry-in is high, while both inputs are low, then sum is high too, and carry-out is low. When carry-in is high, while only one input is high, then sum is low and carry-out is also high. When carry-in is high while both inputs are high, then sum and carry-out are also high. If carry-in is high, then the output values change as if we had added one to the full adder. Okay, now let's test our circuit in a real environment
using the Terasic DE10-Lite Intel FPGA board.
Note, as it can be seen, this circuit is already prepared for the FPGA tool export. See our previous video,
Programming a Terasic Intel FPGA board with TINACloud
using schematic design entry. Now let's see how to generate the source file
for Intel Quartus Lite.
Click the TNM menu and select
Export to FPGA software. Then click Intel Quartus.
Next, open and extract the full adder VHDL
DE10-Lite FPGA export.zip.
Create a folder. We'll name our folder Designs. Then copy the 3 files,
including the 2 VHD and 1 QSF files,
into this newly created folder. Note that TINACloud always creates a VHD file from any type of representation of the digital circuit. That is, schematic diagrams, VHDL, Verilog codes, or their mix are always translated into a VHD file
for Quartus. The QSF, Quartus Prime settings file guides the FPGA software, for which the physical pins on the FPGA will be the inputs and outputs. The QSF is made from the FPGA pin settings we made previously.
To produce downloadable content,
we first have to create the Quartus Prime Lite project. Start Quartus. Select File, then click New Project Wizard. Enter the working directory name, in our case, C:\designs. And the project name, Full Adder VHDL DE10-Lite.
Click Next. Click Next again. Now,
add the source file.
From the Designs folder, select
the e-half-add-entity.vhd and the Full Adder VHDL DE10-Lite.vhd files as source files.
Then
click Open.
Click Next.
In the Family Device and Board Settings dialog, under Device Family, select Max 10. Now, you can manually select the 10M50DAF484C7G FPGA from the available devices.
Click Next.
Leave the EDA tool settings on default.
Click Next again.
Finally, press the Finish button. Now, Quartus is initializing our project. We can check the Full Adder VHDL DE10-Lite.vhd file. Copy the entity name and set it as the top-level entity under the Assignments menu point. Click Assignments and select Settings. Paste the entity name into the top-level entity field in the dialog. Click OK. Let's add the QSF file as well. Click Assignments and select Import Assignments. From the Designs folder, select the Full Adder VHDL DE10-Lite.qsf file. Then, click Open. The content of the QSF file will tell the software which FPGA pins are to be used for the logic inputs and outputs. Click OK. Now, to produce configuration data for the FPGA. Right-click on Compile Design, then click Start. Now, connect the DE10-Lite with the Quartus machine via USB. As soon as the Quartus Prime full compilation was successful message appears, right-click the program device. Then click Open. Click the Start button to program the device. You will see the progress bar at 100% successful message. And the conf LED will light up on the board.
Now let's see how our simulated full adder circuit works along with the programmed
DE10-Lite hardware.
To have a closer look at
DE10-Lite hardware,
we'll now zoom into the area of the 3 switches, SW0, SW1, and SW2, and the corresponding LEDs,
LEDR0 and LEDR1.
Start the simulation by pressing the interactive dig button in TINACloud. We'll change the virtual switches in TINACloud by clicking them on the screen. And at the same time, we'll also change the real switches
on the DE10-Lite board.
When both inputs are low while carry-in is also low, then sum and carry-out are also low. While just one input is low while carry-in is low, then sum is high and carry-out is also low. When both inputs are high when carry-in is low, then sum is low and carry-out is high. Now let's see what happens when carry-in is high. When carry-in is high, while both inputs are low, then sum is high too, and carry-out is low. When carry-in is high, While only one input is high, then sum is low and carry out is also high. When carry in is high while both inputs are high, then sum and carry out are also high. As you can see, in all cases, the results are exactly the same. This is a great example of demonstrating the power of simulation, since you can test and debug circuits even before realizing them, and in our case before downloading to FPGA, where if there were any issues, it would be extremely hard to find the problem. This concludes our video tutorial of programming an FPGA development board using VHDL macros with TINACloud's built-in digital components. Check out our other video,
Programming a Terasic Intel FPGA board in Verilog with TINACloud,
where we use a Verilog component in FPGA design. For more information, visit our website, www.tinacloud.com. Visit our YouTube channel, www.youtube.com/user/Tina Design Suite.